In this video, I want to talk about the axes of the Mendel Falcon. To start, I will explain the slides for the axes. And I decided to go with 3/8 inch polished linear rod from a master car. And the reason I did this is because it actually was relatively cheap, came in lots of different sizes, and it was required. One of the specs for the bushings I used was to have a rod with a certain, I think, 9 nanometer surface finish or something like that. But it was the rods that were spec'd for the oil light bushings. And that brings me to the bushings. I went with oil light bushings because they are freaking awesome. And reasons I like them is they are self-lubricating, so the maintenance is a lot lower. They're cheap. I mean, these ones here were under $1 each, and they actually are rated for really high, they're rated really well. Like the PV rating is like 50,000 in standard units. I'm not sure how that converts to metric units, but maybe it's the same, I don't know. But the P, the pressure, and the pressure can handle somewhere around, I can't remember what it was exactly, but the load for this size of bushing, they're like something ridiculous, like 500 pounds each or something. And then the velocity is something like 30 feet a second or something like that. It's pretty ridiculous. Way more than I'd ever need. So I really like that. I was looking at some other bushings. There's a lot of fancy ones that are some special, I don't know, you have ceramic rods and, I don't know, really, really awesome fancy like dryland bearings or something. And, they're really expensive. They're like $10 each, and their ratings weren't as high. So, these aren't in a really chemically demanding environment, and these are just fine, I think. I think they're actually really good. Another thing I did is I made sure I sized them so that if I was to decide I didn't like these and wanted to go with a linear bearing, that I would go, I could switch out without reprinting new parts. So this is a standard size. It's 3/8 ID, 5/8 OD, and I believe it's 7/8 inches long, which is a standard linear bearing size that I was able to find for relatively cheap. But I actually really like these bushings, and I like them better than linear bearings. I think they seem to run quieter. The friction is just as low as far as I can tell, and yeah, they work great. So to get onto the design of the axes themselves, I kind of had a certain, I guess, philosophy when designing it, and I wanted to make it as ideal as possible. And in my mind, the most ideal axes will have a very low mass. X-axis is one reason why why a lot of people use bone extruders, because lower the mass, you get the stepper motor out of there. Really makes it so go faster and just better in that regard. So I wanted it low mass, and I want the mass to be directly in between the guide rails, and I want the drive belt to be positioned right on the center of mass. And I didn't get it perfectly, but this is the best compromise I could come up with as far as getting the closest to old values while maintaining everything else fitting together. And this is the geometry that I came up with, and it works really well, so I'm happy. And the reason why I wanted to have center of mass between the rails and the drive belt on the center of mass is so that I'm not inducing any like moment forces on the whole setup. And I've noticed problems with my Prusa Mendel, especially in the x-axis, where as it's going back and forth, the the axis is a little top heavy, so when it stops, it like rocks back and forth if I'm trying to go too fast, and it really limits my speeds. One of the things that really limits the speeds. There's multiple, but that's one of the big ones. Okay, aside from that, you know, the y-axis is kind of really the same philosophy. You know, I wanted to position the rods towards the edges, and that's just so if there is ever like a, you know, if there ever is wear, you know, noticeable wear in the bushings, any of the slop will, it won't affect the whole axis very much. You know, the closer together you have the bushings, the slop will translate larger towards the edges. So I wanted to just minimize that and have a nice stable build platform. So that's kind of what I came up with. And the same kind of deal with the drive belt. Wanted it kind of in the middle, you know, really low profile, sleek, in between where the drive, you know, in line with the center of mass. And this is kind of the geometry that I came up with. The Z-axis, nothing really special about that. Uses the same bushings, and I went with an Acme threaded rod. 12 turns per inch. You know, I probably should have gone for the 16 turn per inch or some other thread pitch, but this was kind of one of the cheaper ones that, you know, that was available at the length I wanted, and had the cheap nuts, Acme nuts to go with it. So this is kind of what I ended up going with. As far as the extruder is concerned, playing with a dual feed extruder right now, dual hobbed bolt, and just kind of trying to make it so that I can really print at higher speeds. And I was having problems with my other feeder chewing up filament, and you know, it might have been a tension issue or a temperature issue at the hot end or something of that nature. But I'm still kind of working the bugs out on that front. I may not choose this design in the end, and don't laugh at my color scheme because I was running out of filament, so I had to kind of just use what I had, and that's why green and blue, whatever. All right, I think that's about it. Guess I can talk a little about the X carriage, because that's kind of interesting. I ended up using an LED heatsink, and this is from Mauser, and it's like $2 or $3, really cheap, but it actually works really well. You know, you have threaded there's like mounting holes that go around, like 4 of them on each side, and you just tap those out and drill a hole through the middle for the filament to go through. And it's a really good setup. I really like it. It seems to work well, and it gives me leeway if I want to, you know, attach a old metal hot end. This will dissipate a lot of heat before melting all the plastic it's attached to. So I really like that as well. The slides were a little trickier. I need to redesign the slides a little bit probably. To get them aligned, it wasn't as easy as I would have liked it to be. It wasn't nearly as easy as the y-axis to align. So I'll probably change that up. The y-axis is really easy to adjust and get straight. I can even just pull this off. I just have little clips here. All I gotta do is pull the clip off, slide the bushing out. You do that 4 times and this whole build plate just lifts off. Really easy, and it is just as good. It was perfectly stable, rock solid, really good setup. That's about it. Other than that, you know, just you know, made tensioning knobs, make it really easy to adjust the tension on the drive belts. I wanted to make sure that the belts were parallel, had good belt alignment. I had problems before where on the other printer I have it, you know, when it gets close to the edges, the angle changes on the belt, so it binds up, and I wanted to alleviate that. And the same thing with the y-axis, nice and parallel and straight, and no binding towards the ends. And that's about it.